speaker is Dr. Susama Sudhishri, and she's a principal scientist at IRI. You can see that. So, Susama, you want to say something more about you? And we'll suggest, please.
Good afternoon, everyone. I am the principal scientist. My discipline is soil and water conservation engineering, working since 26 years in ICS system. First, I worked at earlier Central Soil and Water Conservation Training Institute. Now it is IISWC, and from that institute at the research. You will see this YouTube that has been told during 2021 since 2 years. And when Dr. Syed Esmail sir having the webinar, series of webinars, and this concept of biofertigation, and Dr. Indramani Minister sir was introduced me during that period, and this working sir, and that has not been completed. So within 15 minutes now I am going to finish so that I will get the suggestions from you all to further improvement and further research. So next one please. Next. So these are the steps. When we are doing about the biogas, we went to step 3. That is techno-economic evaluation. So first lab study, then the filter development, then after filter, once it has been filtered, that filtered biogas digested, that liquid part we use in 340 liters. So how we did that? Next slide please. Monsoon and post-monsoon season. The biogas plant, that is in IRI, that is integrated farming system. From that we have took this biogas slurry, and we study now also we took the two from another two places, that is from Uttar Pradesh and also from Delhi, one farmer in farmer field. So those we have collected and those this is characterization. So what is the total available NPK, total NPK. After that, we studied what is the outlet, whatever the liquid for slurry we got. So we have studied is the NPK content and other parameters also of this sedimentation process. Next slide, please. One most important is when we are using the biogas slurry, directly if you use, there will be clogging. You know that is the particle size we got, that is 2.07 millimeters. But you know that is very less, more than the emitter size. So if you use that, maybe clogging, that will clog the drip emitter. So these are the different ratio which are tried, and we found 1:2 ratio. First 1:2 ratio is the best. That is slurry 1 and 2 part of water. Then next slide please. So these are the different parameters, effect of a filtration efficiency, how it occurs during this 1:1, 1:2, and different treatment of PGS. There are 33 combinations we do. Different 33 combinations we do. Then I will find out which one is the best. That's so this is the system. What we develop the 5 types of filters. This is the first one is the there is the agitator. And these are the hydraulic part. So suppose what is the uniformity coefficient, emission uniformity, what is the coefficient variation in emitter, and this emitter flow variation, application of clogging ratio. So these things we have also studied after filtration. Next slide please. And also we have calculated, if you see the combination of 80% of RDF plus DSL. That means we are saving 20% of chemical fertilizer due to this. Though we are getting the less available nitrogen, still then we are getting the good result. BC ratio, if you see, we are taking the 10% like period, and if you see the 80%, 1 year or 4 months is the phase as period with 2.29 BC ratio. So my overall conclusion is the cascade filter system with 1:2 ratio of slurry and water, and 3:1:1.5, 3 part of P pebble, 1 part gravel, and 1.5 part of sand. So that is the best one. And then 80% RDF plus what is the filter liquid we are getting. Then BC ratio 2.79 and payback period.
We have to take it. We have to develop nanomotors, work on every emitter, handle all kind of mess. This is work going on MIT. So I'm on the committee there. So we look at it. So this is a new area of challenge. We work on nanomotors. Then we can handle the slurry, apply anywhere. Okay? On individual motors. Yes? You want to say something more? Okay. Yeah. Any? We still have.
Can I answer?
Yeah.
There is not much plugging. Since whatever the slurry we are applying through agitation, then it is flowing to filter system. So all the solid material it is in the PCS, pebble channel. So we are getting good, and plugging efficiency is more than 80%. What we have received. So that is the problem. Is two things here the problem. After filtration, available NPK is less. So next, what we are working upon is we will use after filtration. We can use a biofertilizer since we are talking about organic farming. So that part we are working upon that. How much biofertilizer we will have to use according to the nutrient requirement of desired crop. Which crop you are going to take? So according to that, we will have to apply how much biofertilizer. So that part we are working. Again, we are working to reduce the particle size. Since the particle size of biogas slurry is 2.07 millimeter, but the emitter size is very less. So that part also we are working in IRI. Sir is there. Sir, we have already talked about Pusa decomposer. So we are working upon that. We are adding the Pusa decomposer to the slurry before filtration, so that the particle size will reduce and it will pass through these pebbles and gravels, so that scaling part that can be reduced. And also yesterday I talked to Dr. Murthy, and he was asking about suggested me about what is that basket.